All right, folks, we are back on go, and we are finally into Chapter 6. So, Chapter 6, we're getting back to regular geometry. We're done with the algebra review, so you can see a couple things that we're going to talk about and go through those. So, the first thing we want to talk about is what is a, remember what a polygon is. It's a figure that we're going to use in geometry. So, polygon interior angle sum. So, what we have here, folks, is we have an equation that says the sum of the remember, interior angles of an n-sided polygon, and then we have a formula. So we want to use the formula n minus 2 times by 180, and n equals the number of sides. So in this example, count your vertices, 1, 2, 3, 4, 5-sided figure, 5 minus 2 times 180, so 3 times 180. The sum of the interior angles in this problem is going to be 540. And this kind of walks you through how it was kind of figured out. So if you break a four-sided figure here, so 1, 2, 3, four-sided figure, and I probably shouldn't have marked that because they're not all the same. A four-sided figure into two triangles, 180 plus 180 is 360. So this just kind of sees you mathematically how they came up with that equation. So again, here's the equation. So same type of an idea what we have here. So a triangle is a three-sided figure. 3 minus 2 is 1. 1 times 180, 180. A four-sided figure, quadrilateral right here. 4 minus 2 is 2. 2 times 180, 360. And again, this is the sum of the interior angles. Interior angles, that's important. Here we have a five-sided figure, pentagon. 5 minus 2 is 3 times 180, and we get the 540. So again, that's how do we find the sum of the interior angles. So if you don't know some of these names, there's a chart on page 394 which gives you an idea of what we're at. So hopefully we know what a hexagon is. Hexagon is a six-sided figure. So we're going to go 6 minus 2 is 4. 4 times 180 is 720. Next one we have is an octagon. Octagon is an eight-sided figure. So hopefully we can plug that in. 8 minus 2 is 6. 6 times 180 is 1080. And that is the sum of the interior angles. Again, interior. So that leads us, this one here is a nonagon. That's a nine-sided figure. You can see that, same idea, same concept. So now we're going to apply that to a polygon. So this one says find the measure of each. So again, that's the key, each interior angle. So the first thing you want to start with is what is the sum of all of them equal to? So the first thing we think about is how many sides are in this figure. It's a four-sided figure. 4 minus 2, oh, that's weird too. 4 minus 2 times 180, and that gives you 360. So you know that all of these angles we're going to add up, set up an algebra equation, and set it equal to 180. So 11x plus 4 plus 5x plus 11x plus 4 plus 5x equals 360. And again, we got 360 from our equation, sum of the interior angles. Now we would do basic algebra, 11x plus 5x plus 11x plus 5x. That's going to give us 32x. 32x plus 8 equals 360. You subtract the 8 over, you get 352 equals 32x. And then when you divide by the 32, you find that x equals 11. But what was the original question? The original question, again, remember geometry before we took this algebra break, is find the measure of each interior angle. So again, we go back to plugging it in. So 5 times 11, these angles are 55. These angles are 55. And then again, you plug it into the other ones. You go 11 times 5, 11 times 11 plus 4. So that gives us 125. And then this is 125. So that way we found our x and the measure of each interior angle. Each interior angle. That's the same idea there. This is the same type of problem. I'm not going to do this one for you. Hopefully you can solve this one on your own. Show your work, get your final answer, check it with mine, and then you get the answer is C in this case. C in this case. Same idea. Four-sided figure set equal to 360, add them all up, and then find the value of x in that case. Next concept here we want to talk about is the exterior angle. So again, what is an exterior angle? You can see hopefully right here, this is angle 1, that is outside. This is inside, that's the interior. The green dot is the exterior, that's the outside. So the sum of the exterior angle measures of a convex polygon is 360. So that's the sum of the exterior measures. So what if it's a hexagon? What if it's an octagon? What if it's a heptagon? All of them are 360. Doesn't matter how many sides. These are exterior angles. All of these are 360. So remember, exterior is 360. Interior, we have to use the formula to get there. A couple other things we want to remember. What is concave and convex? So this on the left here is convex. Nothing passes through the middle. Concave, if you can see all these sketches here, these go through the middle of the object. If you go in the cave, it's concave, otherwise convex. A couple other things to remember, exterior and interior angles are supplementary. So this is an angle here. If this is 120, that's an interior. This is 60, you just subtract from 180. If this is 75 right here, what is this going to be? 180 minus 75 gives us 105. So those are things that we learned before. Hopefully we can review those and still have a good understanding. What is a regular polygon? Means all your angles are congruent and your sides are congruent. And we stated already, the measure of an exterior plus the measure of an interior equals 180. So in this example right here, it says find the value of x. So the first thing we look at is what type of angles are they giving us? These are called exterior. And again, you can look to see how many sides of this object that we have, but it really doesn't matter. We know that the whole thing has to equal 360. These are exterior angles. So you would take each expression and add them up and set them equal to 180. So 5x plus 5 plus 5x plus 4x minus 6 plus 5x minus 5 plus 4x plus 3, I think I'm running out of room here, plus 6x minus 12 plus 2x plus 3. So you're going to add all those up. You're going to combine your like terms, combine your other values. So again, if you add up all these, so 5 and 5 is 10, plus 4, 14, 19, 23, 29, and 31. So 31x plus how many regular numbers do we have? It's easier to add here. 5 minus 1 is negative, minus 6 minus 1, minus 6, minus 3 equal, so we're actually minus 12. 31x minus 12 equals 360. So you add the 12 over, so 31x equals 372. And when we divide that, we get that x is 12. Final answer, x is 12 here. And if they asked you to find all of the angles, then we would plug that into all the x's and we could find the measures of all the exterior angles. All right, next one, folks. And that just walks you through, there's all the work there for that specific problem if you want to double check work. Next one, same idea. We did not actually solve this one, but another problem if you want to practice. Now we want to take a look here at this question B. It says, find the measure of each exterior angle of a regular pentagon. Okay, so again, we have to think about a couple things. First of all, what exterior means that all the angles add up to 360. And then how many sides does a pentagon have? It has 5. So you're going to go 360 divided by 5, and that gives us the answer of A, 72. So if you wonder how I got that, I came up with a few equations on the next slide here. Maybe kind of help us out to answer some of these. So if you want to find the sum of the interior angles, then you use this equation, 180 times number of sides minus 2. And again, if you have to work backwards through that, you can work backwards. This right here, the second one is just the sum of the interior angles is 360. That should help you out just to know in general what that is. Number 3, If you need to find the number of sides n, you can take 360 divided by an exterior angle. And the last one, if you need to find the measure of an exterior angle, 360 divided by the number of sides. So those kind of equations should be able to help and guide you through when you get to the homework. Next example here, it says the measure of an interior angle of a regular polygon is 144. Find the number of sides of the polygon. Find the number of sides in the polygon. So let's go to this one right here. I don't know if I had that one on the sheet. So the measure of an interior angle of a regular polygon is 108. Find the number of sides. So if you go back to that previous formula sheet that I had, so this is a measure of an interior angle. So we know that we want 360 divided by an exterior angle. So we want 360 divided by an exterior angle. So what do we have to do? 180 minus the 108, because that's an interior angle, that will give us an exterior angle. So that's 72. So 360 divided by 72 gives us the number of sides, and the final answer is 5. So 5-sided figure. The next example here says find the number of sides of a regular polygon if the measure of an interior angle is 135. Same concept we just did in the previous problem here. So we're going to go with 180 minus the 135, and that gives us a total of 45. So that is the measure of an exterior. 360 divided by that 45 gives us a 8-sided object. 8-sided object. Last one here, we want to find the measure of an interior angle of a regular heptagon. So regular heptagon. So first of all, you have to know, well, what is a heptagon? Heptagon is a 7-sided figure. So the first thing we want to do is we want to find the measure of all of the sum of the interior angles. So remember that was 7 minus 2 times 180. So 7 minus 2 times 180. And that's going to give us the sum of all of the interior angles. So that gives us the sum, but it says find the measure of an. An interior means you want 1. So what do we have to do? We have to divide by the number of sides. It's a 7-sided figure, and that gives us the measure of 1 interior angle is going to be right about 128.6 degrees. So a lot of stuff to cover there. Back to the world of geometry and using algebra to get there. I'll put the assignment on the slide. Great job, and the notes.